Hello and welcome to today's Tech Talk on preparing for production, best practices for OR and decision science teams. My name is Haley and I'll be supporting today's session. I am joined by Carolyn Mooney, CEO of NextMove, and Tiffany Bogich, Head of Product at NextMove. And they're going to be walking through a lot of good content today. They are going to begin by setting the stage with an overview of what model development looks like and what it could be under the guise of best practices. They are then going to dive into the bulk of today's session around best practices. They'll be reviewing some patterns, actions you can take, and showing some examples. And then finally, we'll save some time for Q&A at the end. If you'd like to, please feel free to drop your comments or questions into the chat off to the side. Just be mindful of that hosts and panelists versus everyone toggle to make sure that your message goes to the right audience. Additionally, there's the Q&A feature at the bottom of your screen. You're more than welcome to drop your questions or comments in there. We'll be monitoring that throughout as well. So with that, I'm going to hand it off to Carolyn. Take it away.
All right. Thanks, Haley. Appreciate it. I'm very excited about this talk because it's something that comes up a lot in threads on social about decision science and also just in general in our space. And so one thing that we know fundamentally is that we build a lot of models, but a lot of them don't make it to production. So been a stat recently that 85 to 90% of decision models that are created, or even data science models that are created, never reach business value, right? So they're never live in production, providing value to the business. And one of the major reasons for that we see is that there is like a twisty maze of passages that you have to get through in order to go from local development and prototyping to a testing and production environment. And when we say production, we mean it's in the hands of business users as part of their process, right? Or it is in a live system and integrated right into a more automated workflow. And right now, that process can take months for a lot of teams, and that's because there's like kind of a lot of opacity. There's like ad hoc processes that have to happen. It's unclear, and there's just like time consuming and a lot of handoff between teams. And so what we're going to talk about today is some best practices to simplify that process, to make it more clear, to make it more transparent and repeatable, and to move us from local development that kind of looks and feels the same every time we do it, regardless of the decision domain, to a testing and production environment that is the same, right? So we want to make sure all decisions look and feel the same. And by having these best practices in place, by having these frameworks in place, we can really shrink that time to value down to days or weeks instead of months, right, for these decision models hitting our production systems. So let's dive in here. So this first best practice is really kind of our overarching key for the day. So if there's one thing that you can take away from this talk today, please, please, please make sure it is this one, which is to treat models like applications. Often in our space, a lot of modelers don't treat their models like software. And that's hard because we want to integrate these decisions usually into automated systems or at least automated workflows or augmented workflows. And so observing decisions and their quality can take a lot of detective work. We see this all the time where teams get stuck kind of in that feedback loop between their business team and themselves, understanding kind of what went wrong with a decision model they've created. Experiment results can get overwritten quite regularly. I know I'm guilty of this, even in local testing, where things may be overwritten as like final two or final, and I have to go back and figure out what I did. And then finally, sharing the status of a decision model can be quite hard. So as we go along here, Tiff is going to provide us some action, some tangible things that we can do to make these patterns less prevalent in our world. And so maybe Tiff, you can kick it off at a high level and then we'll dive in.
Yep, great. Sounds good. So yeah, the first thing of starting to treat models like software is separating your configuration and input from the model code. This unlocks things that we'll talk about later, like experimentation and reusability, and just makes your model less brittle over time. And then second is to record your run history. Each run gets a unique ID with the timestamp, who ran it, what version. Again, helps with reusability and collaboration. And it's just good practice in the software world and something we can really benefit from as modelers. And then third, experiments should be tracked and not just the experiment itself, but all the input output associated metrics and visuals, and in a way that is searchable. So it's easy to, answer the question of what happened last Tuesday. You can go through and really kind of take those inputs and outputs and run experiments with them. And then finally, standardizing your decision ops workflow. So what does this look like? Pretty much every time you have a new model, you follow the same workflow. And Nextmove provides a free and open source framework for this. So we'll double click on all of these points throughout the talk, so I won't belabor them just yet.
Yeah, sounds good. And here's an example of maybe at a high level what that looks like. So within Nextmove, this is an application for a simple knapsack model, but you can see, that we have a record of all of the runs, and then also just like some screenshots here of what maybe an API around our decision model could look like. And so, as Tiff said, we'll double click on these as we go along. So the first one here that we'll dive into is keeping model code and input and output separate. So this is pretty core to some of those reproducibility keys that Tiff was talking about. And the patterns we see here are that models can oftentimes be embedded into service code. And this is because maybe your modeling team or you as modelers are working directly with a software team, and they are taking your code and then kind of putting it directly into their service code. This could also be because you are collecting data from multiple sources. And so kind of the API level is to kind of go and reach out to collect those different data pieces or like the state of the world when you're making your decision and then passing it to your model code directly in that service. But this basically makes it so that teams can't easily determine what data was used for the decision itself, and reconstruct that decision. So replaying models outside of the service architecture is something that slows down a lot, or being able to find data. We had one team that told us that maybe it took a whole day to kind of dig through, S3 buckets, right, and data storage to find a particular input, right, for a model and to kind of reconstruct it from multiple sources. So Tiff, maybe we can talk a little bit about the actions that we can take to avoid this.
Yep, definitely. So the big thing here is making your decision model its own microservice. So your model should have one job. It reads input, makes a decision, and writes output, and that's the microservice. And to do that, you need to separate out data collection code from the actual decision code. And so what I mean by data collection code is just all the upstream stuff. So querying databases, maybe calling third-party APIs to pull together other data sources, aggregating that data, that should live in a different layer. So the model just receives a clean input file, and it's easier to reason about that way as well. And then along those same lines, just make sure your model reads input, writes output, and then stores data files that are passed into and out of it. Splitting those layers really makes it maintainable and easier to iterate on in the long run.
Yeah. And I really like that because it kind of separates concerns, right? Like you don't,
Yep.
and you can kind of see where things are kind of failing in the process. So this is an example of your routing workflow on the Nextmove side. We call them decision workflows or pipelines. You could also build pipelines in other tooling. So there's, Airflow or Dagster or a variety of different service layers. And oftentimes that is what kind of where your software team is coming in to kind of build that pipeline around your model as an artifact. But you can see here that this is a very common kind of pipeline that we see, which is fetching and preparing data, like Tiff, you were just mentioning, then passing that data collected and transformed into your model, running that as a separate component, which you can see there is the routing app, right, and then doing some post processing, right? So you can kind of use these steps independently in other parts of your system as well. So the next best practice is really about making parameters configurable and not hard coded. This burned me the other day when I was making a simulation example with SymPy. I actually didn't expose a seed value, and then I was trying to reproduce things and having to repush a version because it was hard coded. The seed value was hard coded in the example that I pulled. So the patterns that we see there are one, a lot of our examples that we have in this space do tend to kind of like hard code some things just for example purposes, which makes sense. But from a production application standpoint, people will always want to play with parameters. This is my number one learning from my time at Grubhub and Lockheed is that business users want to have levers that they can pull and that they can use to reason about the decision that is being provided by the model, whether it's a scheduling decision, allocation decision, et cetera. And that's really because they're handcuffed by the automation in some ways, right? They're supposed to leverage the automation to make their decisions and to impact their cost or revenue, right, or bottom line. And so you want to make things available to them so that they can have a good intuition about the decision and also a good intuition about what's possible. So changes in config, can require a lot of like lengthy redeployment, like what I just said. If it's hard coded, you have to redeploy like the whole model. And then the business model or software loop can be really inefficient in that way, right? If they want to change one parameter and you have to redeploy, that's not great. And so the model, not being flexible enough for reuse there can cause a lot of friction. So Tiff, talk to us about some of the ways to avoid this.
Yep. Yeah. So the first thing is to make your model read configuration or parameters from the environment or command line. So this makes it possible to test different scenarios without waiting for the modeler to go in and change the model because they're all embedded. And along that same line is one of the ways to do this is to scan your code for hard-coded numbers. Look for these kind of magic numbers in your code, especially in your objective function coefficients. So like if cost per mile is 1.5 and it's in your code as 1.5, expose it as a parameter so that you or others can tweak it down the line. And then some best practices for exposing those parameters is to set defaults. Set a default that works 80% of the time, but make it easy to override and have rules for those overrides. And then validate ranges for parameters. So put guardrails on your parameters so someone who's not familiar with the model or even someone who wrote the model can still interact with it in a smart way. And I know, Carolyn, this one bit you the other day when you set a minimum allocation for a warehouse to be higher than the total demand, and you got an infeasible result, and it was confusing because you didn't have those guardrails. So it hits all of us.
Yes, it certainly does. And I think it's extra important, obviously, too, in the like age of agentic systems where you might have bots interacting with your
Yeah.
models as well, right? So setting those good context clues is great. And an example of this on Nextmove is really what we call options. So same thing as parameters. You can decide kind of what you want to expose as an option in our system, and then use those when you're creating new solves, right, or new runs or new plans. And so you can see here, maybe you have something like solve time. We'll get into this a little bit later, but that's a frequent one that we see as an option, right, to kind of limit the total amount of time you spend in the decision-making process. And then these are some specific ones to my machine shop scheduling, example that I was playing with. But these are all ways to kind of give some control to your planning team. And obviously the actual input data itself is a big key to that as well. So kind of a combination of input data, what should live in the input, and what should be configurable kind of at a global level or global scale is something that is always a nice conversation to have. Best practice number 4 is making model versions accessible. This one kind of came up recently in a conversation that I was having with someone that was interested in Nextmove and thinking that we were kind of a replacement for Git. And I want to make sure that it's clear, managing model code is different than managing the use of a model, right? And the use of model versions. And so oftentimes in the world of decision making is very valid to have 3 or 4 different formulations or versions of a model, or even different technologies underlying those versions live at any given time. We definitely saw this in our work at Grubhub, and I saw this in my work at Lockheed as well. That you might have a situation where you have maybe 3 mixed integer programming versions that have some different constraints or formulations, and then you have a heuristic that's a fallback. And these could all be very valid to use for, a scheduling decision, for example. And if you don't have those versions available in a consistent way, modelers, right? We as modelers become the bottleneck or like single points of failure because we're the kind of we hold the keys to access to those models. And so we want to get ourselves kind of out of that bottleneck and make sure other people also have access to those same configurations and model versions over time. And then by doing that, we kind of can simplify the rollout and rollback, right, process. And I think that is a really tricky one today, where if you're not allowing multiple versions to be live, rollback and rollout are both very difficult because they require a lot of software interaction.
Awesome. Yeah. So, I mean, as you mentioned, I think in the spirit of treating models as software, using software tools is the biggest thing we can do. So use Git for managing your model code. Saves you from having, I don't know, model v2 new objective coefficient 2.py as a file name for your model. It just makes things a lot more sane for tracking versions and changes and collaborating on that code. Um, and then another best practice is to have a model registry. So this means having access to different model artifacts under the same API. And so that kind of gets into the next point already, where you have that common API layer in UI, and it makes things like run replay, A/B, or shadow testing possible. And kind of from there, the next thing to do is to decouple the model version from the actual API endpoint. So decoupling the model version from the service itself so that you can easily roll out and roll back, as Carolyn was describing, new versions without having to redeploy the entire system and going like relying on a separate IT team maybe to redeploy that service. So it saves a lot of headache and makes things much easier to manage.
Yeah, for sure. And here's our example in the next move world. So an example of that model registry might be, you can see here like different versions. These could be tagged, in this way, or they could be have like, git a git commit tag, depending on kind of where you are in your process. And they could also be tagged with technologies, right? Like, so these are all different executables. And like the way to think about this is just that within my decision app, maybe all these versions take in the same input data, right? Maybe they have different configurations, but they could have the same input data. So that's super helpful. And the second thing on Nextmove that makes this possible really is the service layer, right? So Tiff, as you mentioned, kind of the decoupling of service and model makes is what we're kind of doing here. So instances in our world are not instances of a model run. They're actually different endpoints for a model. And so you could see here maybe New York City production versus shadow allows you to kind of separate environments to run your model in. And that means you can tie them to different versions of your model. You could tie them to different solvers or heuristics. And you can also tie them to different compute. And so this is allowing you to kind of have that flexibility of controlling what version is in front of a particular subset of your planning space, right? Whether it be geo or a particular subset of your customer base or whatever it may be. And so that gets us to our next best practice, which might be my favorite, which is, and I think it maybe is yours too, Tiff, from your
Probably.
background.
Yeah.
But standardizing your model testing from end to end. So the patterns we see here in our space are there's not necessarily a direct or consistent testing progression all the way from like unit testing to regression testing or even online testing like Shadow and Switchback. Testing is often ad hoc and hard to share or reproduce. I know when I was at Lockheed, the pattern was often that I would run a bunch of simulations, collect data, build a deck, right, and then have a conversation about it 2 weeks later. And oftentimes I'm kind of losing the context as I move on to other studies, right, or other testing in the meantime. Also another thing that I mentioned at the very beginning was just test inputs are not organized or consistent. So having like consistent naming conventions, things like that, so that you can reproduce. And that kind of leads into the last one, which is conditions not being logged means like they're almost impossible to reproduce, and that can really degrade trust in the solutions for your model overall. So how do we fix it?
All right. So first up, have a documented test plan or test bench progression. So as you're saying, build your confidence iteratively. So have unit tests and then move on to integration tests, regression tests on historical data, and online tests like shadow production, shadow testing, and then use the same test types across all models. So it reduces that cognitive overhead when you're looking at test results. It makes it easier to present new model results. People don't have to think about the chart you're displaying because it's the same every time for that model, and it just makes it easier to move quickly. And then create managed test sets to use with your tests. So curate a standard test suite based on real production data, update that test suite quarterly or even more, it depends on kind of when you're running your model. And this lets you compare new versions of your model in sort of an apples to apples way. So it just make sure you're not missing things like drift if you're using old data sets as well. And then finally log all local and production tests in the same way. So like when you promote something to production, you already have those baseline metrics to compare against, and it just makes for fewer surprises.
Nice, yeah, definitely. And the example that we have here from the next move side is really around that like input set creation. And I think like you touched on something that was pretty critical, which is you can like kind of take, runs from your production history, and that allows you to make sure your test sets are up to date, right? And so, having a way to kind of programmatically take, April runs, right, or March runs, and use those as you start testing going forward can help with things like model drift too, right? Because if you're testing against current production data, We've existed in systems that were growing like 10x to 100. You need to be able to kind of test against, bigger inputs over time and know when you're kind of starting to butt up against, some of your limitations, right, in terms of solve time or something like that. And so you can run things like scenario tests to understand kind of a parameter sweep, right, or sensitivity analysis. We also have ways to do things like shadow testing, which is more of the online testing. So once you're pretty confident that a model is going to be, solid for you, you can start putting it in. You can put it into a production environment and then have it just run in the background against your current production data, and that really kind of builds that confidence at an extra layer that all your pipelines and everything around your model is working correctly in that shadow mode. So now we're getting to our last best practice of the day, which is considering the environment you'll run in. So the patterns we see in this last one are that the model runtime and service runtime aren't well aligned. This could be like things like package versions, Python
Mhm.
versions, other things like that. Or even just like the process in which your business uses the model, right, is not in line with how you think about it running. You also see that the compute setup and costs like are inefficient or inflexible. And what this means, or how we've seen this manifest is maybe I'm running a model that doesn't need a big memory footprint, but I'm running it on a really big machine. That's just extra cost, right, for my business that doesn't need to happen. So making sure kind of the compute is the right level for what we're working with. And it can also be hard to tell when like good enough is achieved. So I know we often talk about optimality and optimality gaps and things like that in our space, but often in the business world, right, there's timing SLAs. And so when is good enough and does that fit, with our system?
All right. So what do we do about it? So first is understanding when you'll see diminishing returns, so you don't need to run longer than you absolutely have to. So this means profiling your model. Maybe you get within 98% of optimal in 2 seconds, and 99% takes 2 minutes, and you just need to understand the trade-offs and kind of decide accordingly what's appropriate for your model. And this goes along with knowing your downstream SLA requirements. So match the use of your model to your process. If dispatch, for example, needs an answer in under 3 seconds, then that eliminates certain exact methods of doing your model. And you can't run it overnight, for example. So design according to your business needs and your business SLA. And then also know what type of compute is needed when. So this is the service side of your SLA. So don't use a huge machine if your model is single threaded. Match the infrastructure to your requirements.
Yeah. No, I think that's a big one, and oftentimes that's like where that interface with our software team usually is coming into play there as well, like giving them an understanding of kind of what the software needs of your particular model are, and an ability to control them over time for different instances. Awesome. And then an example here of looking at least the objective value over time, or kind of like our solution value over time, is something that we're very often looking at in our space, but kind of using this as a way to manage our configuration, right, for runs. So this is an example we have with a heuristic routing solver. You can see kind of getting like solutions early and then kind of leveling off. And so if I were running this in a production environment, I might choose to run this for you know 2 seconds might be good enough, right? For most of my cases. And I can run this, maybe test across a lot of different input sizes and start to see kind of where I'm tapping out for the environment that I have in play today. If you're interested in this, we have started creating a decision ops scorecard that we have in more detail. You can see kind of some of the pieces here from observability, experimentation, orchestration, and collab. Those are the keys that we find most teams are struggling with or maybe not thinking about in a consistent and standardized fashion. So this is a little bit of a preview, and this talk covered a lot of the bases that we kind of dive deeper into as part of the scorecard. But if you're interested in getting that scorecard, we're happy to send it along. And we have a bonus one, which is documentation, which is a very key area, especially in the world where we are starting to give more context to things like agents. And so using AI and having documentation in your model, from your option sets to your compute class, to even the terms of the objective that you're working with, is critical information for those agentic systems to operate on. So a little bit of a sneak preview there for some things we're releasing around MCP and agentic AI in the near future. And with that, let's maybe switch over to some Q&A. So Haley, I'll invite you back on here.
Thank you. Thank you. That was a great rundown. So we've got a couple questions that have come in through DM. And I'm going to start with one that's a little bit higher level and probably ties back into the beginning a little bit there that you shared, Carolyn. But between you and Tiff, you shared a lot of information as far as best practices. Where would you recommend people get started? Like, of the ones that you've shown, like, where's the best place if you were to take a small step? Where would you begin?
I don't know. Tiff, my opinion is probably on configuration, like allowing, like extracting some
Just
configuration
separating.
from your model. I feel like that opens up a lot of doors for the experimentation, and kind of test suite there. So I think like that's probably the number one thing is thinking about where you should have configuration and levers in your model. Maybe, allowing people to turn constraints on and off, or having thresholds extracted as configuration for your model. I think that's like a really, really great place to start because it kind of gives you some of those concepts of having, input and config kind of separate from your model code.
Yep. Yeah, I was thinking of models as services as being the kind of biggest
Yeah.
game changer. And also pulling out input. We've seen that kind of really make things hard for teams that have their input embedded in their model code. So separating those out as distinct services just makes a huge difference.
Yep.
Cool. All right, we got another question that's double clicking on CI/CD workflows. Can you kind of speak to what those might actually look like, what the flow might be, especially, even in the next move context? I know that you touched on that briefly, but what are common patterns that you see as far as leveraging these types of best practices and how they feed into CI/CD that might be set up already?
Yeah, for sure. I would say the most common framework that we see is people using something called acceptance testing on the next move side. And maybe Tiff, if you want to talk a little bit to that, I'm happy to pull up an example kind of here in the background.
Yeah, happy to. Yeah, and this can be something that is automated through things like GitHub Actions, where every time before you can merge a PR, it will run through and kick off an acceptance test that you can go and manually review. So it's a nice example of augmenting the decision maker with these types of tests. And so what this does is you have some criteria where like you always want the objective value to be the same or maybe decreasing if it's a minimization function. And so you can go in and have this like red, yellow, green light interface, which I think Carolyn is pulling up, that allows you to see kind of how your new version compares to the one that's currently running.
Yeah, and I think a biggest thing there is like having that be passive.
Mhm.
And what I mean by that is like you should be just working on your model and like kind of shipping new code and having these tests kind of happen automatically as you create new PRs, right, in your Git repository is like a
Yep.
great way to just like pressure test things. So maybe working with your software team to set up these actions. They're really easy to set up with our new CLI, and we even have a GitHub action that you could leverage right in your own environment. But it can give you kind of these kinds of outputs. So you can see here I was running a new constraint that I was turning on, and so what does that actually do to my environment, and is it okay to ship to production? So, and this was my expectation on it's basically hypothesis testing. So
Yep.
All right, perfect. Well, we're just at time, so I'm going to end us here. So I think there may have been a question or two that we'll make sure to follow up with folks over email. But Carolyn, Tiff, thank you for walking through all the best practices today. A lot of good content there for everyone, and we'll see everybody on the next Tech Talk.
awesome. Thank you.
Awesome. Thanks.